Hi everyone. Today we're going to be talking about linear systems. We're going to use the substitution method to solve, and we're going to be looking at formal checks and special cases. Go ahead and grab a piece of paper and a pencil, and let's get started. So the first thing we're going to look at are the steps to solve using substitution. So step one, we're going to rewrite one of the equations so that one variable is expressed in terms of the other. Solve one of the equations for one of its variables. So it could be either for x or y, it doesn't really matter. Step number two, substitute the expression from step one into the other equation and solve for the remaining variable. Step three, substitute the value from step two into the equation from step one and solve for the remaining variable. And finally, step four, check the solution in each of the original equations. Okay, let's put these steps into practice and try an example. Okay, so our first example, y is equal to 3x plus 2, and the second equation is x plus 2y is equal to 11. So we're going to start the same way that we usually do by labeling our two lines. So the first one I'm going to call equation number 1, and the second one is going to be equation number 2. And then I'm going to substitute my first equation into my second equation. So I'm going to replace the y with 3x plus 2. The first thing we're going to do for good communication is we're going to write sub 1 into 2. Okay, so we have x plus 2 times 3x plus 2 equals 11. Okay, so we're going to expand and simplify and combine like terms. So x plus 6x plus 4 equals 11. And I'm going to subtract 4 from both sides, and I'm going to combine the x and the 6x. So 7x equals 11 minus 4. So 7x equals 7. So x equals 1. Okay, we're halfway there. We have the x coordinate of the solution. We need the y coordinate of the solution. So sub x equals 1 into equation number 1. So y equals 3 times 1 plus 2. Y equals 3 plus 2, so y equals 5. Last but not least, we're going to make our conclusion and state the solution is 1, 5. Okay, so next we're going to do the formal check. So we have our solution as 1, 5, and we're going to check the solution by making a chart, and we're going to check to see if our left side and our right side work for both equations. So again, I'm going to call this equation 1 and equation 2. I'm going to label my little t-chart left side, right side, and this one's going to be for equation number 1. And the other one, same idea, left side, right side, and that was for equation number 2. Okay, so again, my solution we think is 1, 5. So we're going to check 1, 5. Okay, so wherever I see an x, I'm going to replace it with a 1. Wherever I see a y, I'm going to replace it with a 5. Rewriting the equation, so I have y on the left side, 3x plus 2 on the right side. I'm going to replace the y on the left side with 5. And I'm going to replace the x with a 1. And then I'm going to simplify. So there's nothing to simplify on the left side. However, on the right side, 3 times 1 is 3, plus 2 is 5. So therefore, left side equals right side. So far, so good. So we're only halfway there though with our check. We have to check that the solution works for both equations. Okay, so same idea. We are going to rewrite the original x plus 2y on the left side first. And 11 on the right side. And I'm going to replace my x with 1. And I'm going to replace my y with 5. And when I simplify, I have 1 plus 10, and that's 11. And so again, I can see my left side equals right side. So because the solution is satisfied for both equations, then in fact 1, 5 is the solution. So we can conclude that since left side and right side checks are both equal, therefore 1, 5 is the solution. Okay, let's take a look at another example. So this time we're going to solve by substitution and by graphing. Okay, so I'm going to again start with my labeling. So equation 1, equation 2, and I'm going to sub 1 into 2. Okay, so again I'm going to replace my y in equation 2 with 6x plus 4. So 6x plus 4 equals 6x minus 10, and I'm going to simplify. Okay, so 6x minus 6x equals negative 10 minus 4. So 0x equals negative 14. So because when I solve for x, I'd be dividing by 0, and if I divide by 0, that would give me something that's undefined. So this actually is one of the special cases, so that means there is no solution here. So undefined, so therefore no solution. Okay, so we can check our solution by graphing. So I'm going to graph y equals 6x plus 4. So I'm going to put a dot at plus 4, and I'm going to go up 6 over 1. And if I want more points, I can go back to my original y-intercept and go down 6 to the left 1. Okay, let's connect our dot. And I'm going to draw arrowheads for good communication, and I'm going to label this line equation number 1. Okay, let's go ahead and draw the second equation. So I'm going to put my y-intercept at, from the negative 10, I'm going to go up 6 to the right 1. Then I'm going to go up 6 to the right 1. And we're going to go ahead and connect our dots. So again, drawing arrowheads, and I'm going to label the blue line equation 2. So I can see that my lines are parallel, and that means they're never going to cross or intersect, so there will never be a solution. Okay, let's look at another example. So another special case, so 2x plus 5y is equal to 10, 4x plus 10y is equal to 40. So label 1 and 2. And then we're going to rearrange into y equals mx plus b and substitute in. Okay, so I'm going to rearrange for one of the variables, and we're going to substitute it into the other equation. So if I rearrange equation number 1 for the x, I can subtract 5y from both sides, and then I need to divide all terms by 2. And if you don't like working with the fraction -5/2, feel free to change it to a decimal. Okay, so x is equal to -2.5y plus 5, and I'm going to substitute that into equation number 2. So 4 times -2.5y plus 5 plus 10y equals 40. Okay, so we're going to go ahead and use the distributive property. So 4 times -2.5y, and then 4 times 5. And then we're going to combine like terms and then solve for y. So -10y plus 20 plus 10y equals 40. And I'm going to end up with 0y on the left. 0y equals 40 minus 20, so 0y equals 20. So because I have the 0 in front of the y, again, we're going to have an undefined y. So this has no solution. Also, if you look at the original equations, we have 2x plus 5y equals 10 and 4x plus 10y equals 40. So we can see that they're actually multiples of one another. So when that does happen, then we're going to have parallel lines. Okay, so we can check with Desmos. We can plug in the equations and you will get double lines. So if you want to take a minute and try that, go ahead. Okay, so I've gone ahead and entered the two equations onto Desmos, and we can see that the lines are in fact parallel. So that means there will never be a solution. Okay, let's go back and look at another example. Okay, this is our last example. So x minus 2y equals -3, 4y equals 2x plus 6. So we're going to start by writing 1 and 2 next to our two equations. Okay, so we're going to rearrange equation number 1 for x. So x equals 2y minus 3. And I'm going to sub in x equals 2y minus 3 into the x in the second equation. So I'm going to call this new equation number 3. And I'm going to sub 3 into 2. So 4y equals 2 times 2y minus 3 plus 6. So 4y equals 4y minus 6 plus 6. So when we combine like terms, I'm going to have 4y minus 4y, which is 0y, and then -6 plus 6 is 0. So 0y equals 0. So that actually means these two lines are colinear. So they're actually one on top of the other. And again, we can check using Desmos. So if you want to go ahead and check using Desmos, please do so now. Okay, so I've gone ahead and typed in the two equations into Desmos, and they are in fact one on top of the other. So they're called colinear. Okay, that's it for our examples for today. Thank you. Have a good day. Bye-bye.